Okay, as we move forward in Chapter 8, we're still dealing with quadrilaterals, and you'll have to excuse my voice during the next couple sections as I'm a little bit under the weather. But 8.3 is the exact converse of 8.2. 8.2, you'll remember we dealt with parallelograms, and we went through the different characteristics that a parallelogram has. 8.3 is the exact opposite in that we're proving that the shape is a parallelogram. In 8.2 we said, oh hey, by the way, this quadrilateral is a parallelogram, therefore it has these characteristics. In 8.3 we're saying, if this shape has these characteristics, then it's a parallelogram. So you'll see that we're going in the opposite direction. And let's go through by identifying just a few of the theorems, and you'll see what I mean. Theorem 8.7 says, if both pairs of opposite sides of a quadrilateral, so again, we're just given a quadrilateral, and then they're saying if opposite sides are congruent, then it's a parallelogram. So we're proving that this shape is a parallelogram. Theorem 8.8 says if both pairs of opposite angles, so again, we're just given a random quadrilateral, but if both pairs of opposite angles are congruent, then it's a parallelogram. Then it's a parallelogram. So you'll see the last chapter, or the last section, it said a quadrilateral is a parallelogram, therefore it has opposite angles congruent. Now we're saying if opposite angles are congruent, then it's a parallelogram. So you'll see we're going in the opposite direction. Theorem 8.9, if one pair of opposite sides of a quadrilateral are congruent and parallel. So here you'll see that you have to have two characteristics. You have to have opposite sides, one pair, only one pair, opposite sides congruent and parallel, then it's a parallelogram. Theorem 8.10 says if the diagonals bisect each other, so if you take any quadrilateral and you draw the diagonals and they bisect each other, then it's a parallelogram. And tonight's homework, all you're going to be doing is basically practicing the theorems, the different properties. You're going to be practicing these properties, and just to say, yes, it's a parallelogram, or no, it's not a parallelogram. So here we have some problems that we're going to look at. It says, for what value of x is the quadrilateral of a parallelogram? And I'm going to solve a couple of these just to kind of show you where we're going with it. Here we look at, we'll call this first problem A. We're given that we have two diagonals here, and this 3x plus 1 and this 5x minus 9 are referring to these diagonals right here. Well, if you look at the properties of diagonals in a parallelogram, diagonals bisect each other. Bisect means to cut into two equal halves. So if I take that idea and I apply it to what I know about parallelograms, these two sections of diagonals should be congruent. If they're not congruent, then this is not a parallelogram. If they are congruent, then it is a parallelogram. And because if they're congruent, then they should also be equal, I can set them equal to each other, and I should get a value for x. But then I also need to plug x back in and make sure that my values are actually congruent. In order to solve this, you just use basic algebra, and you already know how to do this, so we'll just solve it very quickly. We subtract 3x from both sides, and I'm also going to add 9 to both sides. I can do it all in one step. What I get are the 3x's and the 9's to cancel. I get 5x minus 3x, which is 2x, 1 plus 9, which is 10. Divide both sides by 2, I get x equals 5. Now, just to make sure that this is a parallelogram, when I plug x into both of these problems, 5 times 5 minus 9 and 3 times 5 plus 1, I should get equal values here. Now, please remember this. We are not in algebra class. We are in geometry, which means good job, you solved that. That's algebra. Now you actually have to answer the geometry question. Is it a parallelogram? 5 times 5 is 25. 25 minus 9 is 16. 3 times 5 is 15. 15 plus 1 is 16. Yes, they are congruent. Therefore, it is a parallelogram. And you can see, and we'll call this one letter B. Letter B is doing the exact same thing. It is telling you that this diagonal is 10x minus 33, and this diagonal is 4x plus 15. If those two segments are congruent, then this quadrilateral is a parallelogram. You can go ahead and solve that here in a second, but I'm going to drop down to what we call letter C and look at these two problems. Now, in order for this shape to be a quadrilateral, or this quadrilateral to be a parallelogram, we have consecutive interior angles here. Consecutive interior angles need to be supplementary. And I'm going to back up to section 8.2 to show you something. The properties of a parallelogram say that a quadrilateral with both pairs of opposite sides are parallel. If we have parallel lines, then we have consecutive interior angles being supplementary. Remember, we reviewed parallel line theorems. And so I can take that and apply it to this section. If these two consecutive interior angles are supplementary, then that tells me that this line and this line are parallel. Good job. But if we go back to being able to prove this quadrilateral is a parallelogram, it's not enough to prove that the opposite sides are parallel. I actually have to be able to prove that opposite angles are congruent. So what I need to be able to do is prove that this angle and this angle, if they are parallel, this angle, and let me highlight it, this angle and this angle are supplementary, but then I also need to be able to prove that this angle and this angle are congruent, because opposite angles need to be congruent. And so the way I'm going to do that is first by solving for this angle, and you'll see what I mean here, because you're going to do the same thing to solve for letter D. Let me erase this problem, because I'm going to have to show a lot of work for letter C. So the first thing I need to be able to do is prove that these two angles are supplementary. Supplementary, remember, means that when we add them together, they should equal 180. So I'm going to set it up like this. Now I'm going to solve a lot of this all at once. I'm going to combine my like terms, 7x and 17x, and get 24x. I'm going to combine my 25 and negative 13 and get 12 equals 180. Now I'm going to subtract 12 from both sides and get 24x equals 168. You can check the math on that. Then I'm going to divide both sides by 24. And when I do that, 168 divided by 24 gives me 7. Now, that doesn't tell me that they're supplementary. That just means that if I add these two angles up and set it equal to 180, I get 7 for x. I actually need to plug this in and find out what these two angles are. 7 times 7 is 49. 49 plus 25 is 74. So this angle is 74 degrees. 17 times 7 minus 13 gives me 106. So I can see here that yes, 74 plus 106 is 180, but here's the thing. I need to be able to prove that this angle and this angle are congruent, and that this angle and this angle are congruent. And the way that I can do that is by setting up similar triangles. I can actually bisect this quadrilateral into two triangles. Or I can actually say this, and this is a little bit easier. We just proved that these two angles are supplementary, which means that these two lines are parallel. Well, if those two lines are parallel and they're cut by a transversal, I should be able to say the exact opposite about the opposite sides, or the same thing about the opposite sides, excuse me, that these two angles, or these two lines, are also parallel. Well, they are parallel because this angle and this angle are congruent. This angle and this angle are congruent. So they are still supplementary, which means that this shape is indeed a parallelogram. Now what I'd like you to do is look at what we did for letter A, how we solved for the diagonal. Look at what we did for letter C in proving that consecutive interior angles are supplementary, which means that the opposite sides are parallel. And I would like you to do that to solve for letter B and letter D. So go ahead and pause the video and do that now. Okay, so hopefully you had enough time to solve for these two problems, letter B and letter D. Let's go to letter B first. You'll see that I started my problem by setting the two diagonals equal to each other. If this is a parallelogram, then the diagonals should bisect each other, and bisect means to cut into two equal halves. So this half and this half should be equal, which is why I set them equal to each other. Then you can see that I solved by combining my like terms on both sides. I moved the 15 over, or excuse me, I moved the 33 over and then moved the 4x over, and I got 6x equals 48. Divide by 6, I got x equals 8. Then I plugged 8 into x on both diagonals, and I got 47 on this side and 47 on this side. So yes, the two sets of diagonals bisect each other, therefore it is a parallelogram. Letter D, I set up by saying that if these two, in order for it to be a parallelogram, these two opposite sides need to be parallel, which means that these two consecutive interior angles need to be supplementary. So I started my statement by adding the two angles together and setting it equal to 180. Combined my like terms, subtracted 6, divided by 29, and I got x equals 6. But then I plugged 6 in to find out what the actual angles are. And I got 113 and 67. Now this is kind of confusing because 113 is an obtuse angle, 67 is an acute angle, but if you look at the drawing, 67 is actually on the obtuse angle, 113 is actually on the acute angle, so it's kind of backwards, but it's fine because you still solved it correctly. We proved that this or that side and that side are congruent, or parallel, and so we could go through and create two similar triangles. We could say that this diagonal bisects this angle and this angle, so we could figure out what these two angles are and prove that the two triangles are similar. And then we could actually go through and start talking about congruency in order to prove that this side and this side are congruent by CP/CTC. But you know what? It'd be easier if we were given side lengths. But anyway, yes, you could say that letter D is a parallelogram also. So again, this section is a little bit backwards of 8.2 because in 8.2 you proved that it is a parallel, or you proved the properties. In 8.3, you're proving it's a parallelogram with the properties. So if you really understood the properties, 8.3 is just a review of parallelograms. So let's go ahead and take a look at your homework now.